Hello everyone, I'm Dr. Sivadas Madhavan, Associate Professor of English. Today I'm going to talk about dispersion, one of the four different divisions of descriptive statistics. Statistics can be divided into two, descriptive statistics and inferential statistics. And in descriptive statistics, there are different types like frequency, central tendency, dispersion, and position. So here, dispersion is the topic today. Dispersion refers to the distance from the mean, the calculation of the dispersion, or how spread out the data is from the mean. Mean is the average. Mean is the average of the data set, or the data points will be calculated together and divided by the number of items. So mean, or x bar, is sigma x by n. X refers to the data points, n refers to the number of data points. So that is average, or the mean. So from a particular data set, from the mean, how far the other data points are spread out. That is what is called dispersion. And for that, in statistics, we have variance and standard deviation. Variance is the squared deviation from the mean. And standard deviation is the square root of variance. So both of them are related to each other. Variance is the squared deviation. We use the square. We square it to avoid the problem of negative numbers. For example, when we take the mean of the data points and when we subtract the mean from the data points, some numbers will be negative. For example, if you consider the example pointed out in the slide, you can understand it. 5 students have got the marks like 10, 20, 30, 40, and 50. So these are the data points or the marks collected from 5 students of a school. And 10, 20, 30, 40, and 50 are the data points. And to find out the variance, you have to subtract the mean from the data points. So when you subtract, see, 10, 20, 30, 40, and 50 will have a total of 150, divided by 5 will be 30. So 30 is the mean. If you subtract 30 from 10, it will be minus 20. If you subtract 30 from 20, it will be minus 10. If you subtract 30 from 30, it will be 0. So this way, some calculations will have negative numbers. So these negative numbers will create a problem. And the sum total of these calculations will be 0, because negatives and positives will make it 0. So to avoid this awkward situation of negative numbers, we square it. And when we square, for example, 10 minus 30 will be minus 20. So minus 20 will have the square 400. Minus 10 will have the square 100. 0 will have the square 0. And positive 10 will have the square 100. And positive 20 will have the square 400. And total will be 1000. 1000 divided by n minus 1. N is 5, number of data points, there are 5. Minus 1. This minus 1 is, we do not divide it by 5. There are 5 data sets, but we don't use 5 because it's a sample. It is not the population. And when we calculate the sample, it's only an estimate. An estimate may not be accurate. So we leave out 1 to avoid that problem of not being complete. So if it is the population, the whole population, you can divide it by the correct number of the data points. So here 1 is avoided. That is the equation. Equation is S square equals, that is variance. The formula for variance is S square equals sigma x minus x bar all square divided by n minus 1. So n minus 1 means total number minus 1. So here for total numbers we have 5. So this total number 5 will be 4 because 1 is subtracted, n minus 1. So 1000 divided by 4 will be 250. So this 250 will be in square. That is variance. And to change that variance into standard deviation, we take the square root. So when we take the square root, we will get 15.8. So 15.8 will be the standard deviation of the data set we have. So here, this example, here we have taken the example of 2 schools, school A and school B. From school A, we have 5 data set, that is the marks of 5 students, which is 10, 20, 30, 40 and 50. And their total will be 150 and their mean or average will be 30. But in the case of second school, we have selected the students, 5 students, and their marks we have seen here 28, 29, 30, 31 and 32. So here also 28 to 30, if you calculate the total, it will be 150. And if you divide it by the total number 5, it will be again 30. So both the schools have mean the same 30. First, school A has the mean 30. School B also has the mean 30. So mean is the same, but when you calculate the dispersion, it will not be the same because the range is different in both the schools. Range means the difference between the highest number and the lowest number. For example, in the first school, in school A, 10 is the lowest and 50 is the highest. So the difference is 40. So range of the school is 40. And in the second school, we have 28 up to 32. So the range will be the difference between 28 and 32. So 32 minus 28 will be 4. In the second school, range is only 4. A great difference between the 2 schools. And similarly, variance will be different and standard deviation will also be different. In the case of first school, the standard deviation is 15.8. In the case of second school, it is 1.58. So there is great difference. And comparing these 2 schools, we will come to the conclusion that the first school has great difference between the marks of the students. That means dispersion is very great. If dispersion is very great, it shows inconsistency or it is less consistent. But in the case of second school, there is more consistency because the standard deviation is lesser than the other school. And when you consider the quality of the school to send your child, you will select the second one, not the first one. In the first school, there is a student who got 50 marks and there is a student who got 40 marks, but you don't select that school because dispersion is very high. But here in the second school, we have 28 up to 32. So you know that the students get the marks which is almost similar to the mean. So the students don't go much below the average level, or the students will not go very high from the average also. Anyhow, a parent who wants to ensure the promotion of the student, or a better result for the student, will select the second school. And this is the practical application of standard deviation or variance. Because the practical application means practically what it means. When teachers teach variance and standard deviation in the class, students are much confused because they don't know why should we learn this. For example, if you ask a simple question that the age of the students in the class is average 20 years with 3 years standard deviation, what does it mean? Average age of the students is 20 with a standard deviation of 3 years. It means the students will have 20 years age, most of them will be 20 years of age, and some of them will be 21, 22 or 23. So 3 years it can go up, or it can go below also. It can be 19, 18 or 17. So it means the spread of the age of the students will be 3 years below or 3 years above. So that is the concept of standard deviation or variance. How far the data points go away from the mean. That is the calculation, and it is needed for the research students, and research scholars depend on it. And not only quantitative research, in qualitative research also students need this for the calculation. So that's all about dispersion. With some other topic I'll come next time. Until then, goodbye. Thank you.